The purpose of this video is to run through the types of Bootstrap confidence intervals that you'll have to construct using StatKey. The first type is a single mean, and this example is clearly that scenario. The word average is in the first bullet point. This is a quantitative variable, and there's only one sample, not two, so single mean, not difference in means. So if we want to construct a Bootstrap confidence interval for a single mean, there's the correct option right there. So if I click on that, the first thing that happens is there's a preloaded data set that I need to get rid of. If you look on the original sample box, there's clearly data already in there, and it's not the data that's in the PowerPoint. So that's the first thing I need to do. So if I go to Edit Data, and then I'm going to delete all this stuff, I'm going to uncheck Data has header row, because in this text file, here I have the sample data copied over from the PowerPoint. This way I could copy it faster in the video, so it wouldn't be quite as long. And now I have that sample data in there. Then to generate the Bootstrap distribution, you want to have at least 5,000 Bootstrap samples. The easiest way to get there is to click on Generate 1,000 samples 5 times. So there's our Bootstrap distribution, and then I'll click on the presentation mode down here to turn that on to make the numbers in the upper right corner a little bit bigger. If you want to construct a 95% confidence interval for mu using the formula where the margin of error is 2 times the standard error, you can do that. The two numbers that you're going to need are visible on the screen right now. Your point estimate, your X bar, is 25.7. It should be the mean of the original sample. So in the upper right, under where it says original sample, that's your X bar, that's your point estimate, the 25.7. The 25.651 that's in the upper right corner of the picture, that is really just the mean of those 5,000 Bootstrap samples in the graph. You don't use that to compute a confidence interval. The other thing that we're going to need is the standard deviation of the Bootstrap distribution, which we can use as a point estimate for the standard error. That's in the upper right corner of the graph. It's the thing that's listed as standard error. So here, 2.708. So a 95% confidence interval for mu would be 25.7 plus or minus 2 times 2.708 if you're going to use that formula to get a 95% confidence interval. The other option would be to use percentiles, which is what happens in section 3.4. If you want to do that, you need to click on two-tail, because then with the two-tail you can specify the proportion in the center, and you just need to get that to match up with your confidence level. So for 95% confidence, that's your default setting, and the endpoints are right there, 20.6 to 31.3. If you wanted another confidence level, you just have to click on this and change it. So 90% confidence, change it to 0.9. There's a 90% confidence interval, 21.25 to 30.2. 99% confidence, change it to 0.99. There, 19.4 to 33. And that's about it. The other thing that's on the screen, I guess I should mention it, is where it says Bootstrap sample in the lower right. You don't actually use that for anything. All that does is that if I bring the cursor down in here, notice how it's changing now. Basically all that does is if I highlight one particular dot in the dot plot, it will give me data for that single Bootstrap sample. That's a nice feature that's there, but it's nothing that we're going to need. You don't need that to compute a confidence interval, no matter which way you're going to compute a confidence interval. The next possible option is a single proportion, which is what we have here. The research department has a random sample of 400 people. Out of those 400, 128 said that they liked it. So we have a sample proportion, a p-hat, 128 divided by 400, and that'll be enough to give us a Bootstrap confidence interval for p. So in StatKey, we want confidence interval for a single proportion. And again, we have an original sample where we're going to have to clear that original sample data out. And if I click on Edit Data, it prompts you for the count and the sample size. As far as the sample proportion is concerned, the count is the numerator and the sample size is the denominator. So for the yogurt, it was 128 out of 400. So now we have the original sample in there. Again, generate 5,000 Bootstrap samples. And there we go. So if you wanted to get a 95% confidence interval using the 2 times standard error method to get the margin of error, I suppose then here you would have 0.32 plus or minus 2 times 0.023. And then if you wanted to use percentiles, just like before with the single mean, click on two tail, and then whatever confidence level you have, you want to specify that in the central region. So let's say 98% confidence this time. Then I've got to click on that and change the proportion to 0.98. There, 0.266 to 0.372 is a 98% confidence interval. This is probably the most difficult one, the difference of means. And the thing that makes it difficult is the way that you have to enter data. It's quantitative data, so you need to get the numbers in there, but you also have to have a way to signify which group each number goes in. So you end up putting the data in like it's ordered pairs. You'll see what I mean. The sample data is caffeine measurements for 2 brands of coffee, and the sample sizes aren't the same, which is fine. There's nothing wrong with that. It makes the table look a little bit empty because there are 10 brand A measurements and 8 brand B measurements, but those empty cells toward the end, that's not a problem. It's okay if the sample sizes are different. Using StatKey, the correct option would be confidence interval for a difference of means. Again, preloaded data set that we have to get rid of. So if I click on edit data, notice how this is done in here. This header where it says label comma value, that's the important thing for entering the data. The label is where you tell StatKey what group each number has to go into. You probably don't want it to be something quantitative. They're using M and F for male and female, and then the numbers are just specified. Like there's a 15 that's a male measurement, a 20 that's a male measurement, an 8 that's a male measurement. Down here you have a 1 that's a female measurement, and a 10, a 3, and a 34, and so forth. That's the idea. So I'm going to dump all this stuff just like we would usually. I've already got this in here in this notepad file, so I'm just going to copy, paste it. So that's the data from the PowerPoint. Since it was brand A and brand B for the 2 brands of coffee, I figured just to use an A and a B for the label. If I click on OK, notice that the sample sizes are correct. N1 is for the brand A sample, there were 10 of those measurements. N2 is for the brand B sample, there were 8 of those measurements. Everything else works the way that it normally would. If you want to construct a Bootstrap distribution to get your 5,000 Bootstrap samples, it's generate 1,000 samples 5 times. Then getting a confidence interval from there. If you're going to use the 2 times standard error method to get the 95% confidence interval, I guess you'd have 2.03 plus or minus 2 times 2.176. And then if you wanted to use percentiles, again, you would click on two tail, and then you can adjust the proportion that's in the central region. The last one for now is difference of proportions. So here we have a mail order company with 2 warehouses, and we want to compare the proportions of orders that are mailed within 72 hours. So 2 sample proportions, 368 divided by 400, and then 285 divided by 300. Using StatKey, the correct option would be a confidence interval for a difference in proportions. So if I go to edit data, then group 1, I suppose, will be the one that showed up first, which was the 368 divided by 400. Group 2 would be 285 divided by 300. Then we can generate our 5,000 Bootstrap samples. And there we go. The way that I input the data here, putting in the 368 divided by 400 first, that sample proportion is smaller than the one that I put in second, so the point estimate is negative. There's nothing wrong with that. There is a temptation to think that that's wrong, but it's not. That's fine. It's order dependent. One order of subtraction is going to be positive, the other one's going to be negative. That's okay. Everything would still work the way that it would before. If you were going to get a 95% confidence interval for P1 minus P2 using the 2 times standard error method, then you'd have negative 0.03 plus or minus 2 times 0.019. And then if you were going to use percentiles, click on two tail, and then you can adjust this if you want to. So if you wanted a 99% confidence interval, change the proportion to 0.99. There it is.